Okay, lesson 12.3, modeling with linear systems. So here we're going to, again, be doing some word problems. So there's the Explore. You look at the first example and explain one that's worked out. And again, a fill in the blank. And we're going to the your turn. So it says, let's expand this a little bit. Write a system of equations to represent the situation and solve the system. The company has to buy computers and printers. Each computer costs $550 and each printer costs $390. And then we also have a total cost here. It spends $8,160. So we have an equation that is related to cost. So computers, I'm going to use a C. So 550 times C plus 390 times P for printers equals $8,160. So standard form here. So again, understanding why standard form is taught, because a lot of times in word problems it becomes convenient. Then the next thing we talk about is the total number of machines. So we have the number, in this case, of machines. So that gives us another equation. The number of computers plus the number of printers equals a total of 16. So now we have our two systems. So how do you want to solve the system? Well, in this case, I would probably do substitution. I would probably subtract C from both sides. And that gives me P is negative C plus 16. And take that, plug that in for P up here, and solve this. So rather than me work all this out, what I wanted you to do is go ahead and try to work this out on your own. And then I'll put the work up and you can check your answer. So you may want to pause the video again. Okay, so what I did again, I put this in for P here, rewrote the equation, did distributive, combine my like terms. Now, again, why I wouldn't do graphing here necessarily, these are really, really big numbers, so can kind of skew things a little bit. But work all this out, do your solving equations, and I get C is 12. So that means I would need to buy 12 computers. So if I put 12 in here, negative 12 plus 16 means I need to buy 4 printers. So 12 computers and 4 printers. Now, let's go back. How many of each did it buy? Well, that's what we got. 12 computers and 4 printers. So again, they give you another example down here. Okay, this one now is an inequality because they're not equal. So now we have our shaded region area, just what we got through doing in module 12.2. So again, you have a fill in the blank one, and then I'm going to go down to the your turn. So make this a little bit bigger again. And let's see if we can come up with our inequalities. And then it says determine if 8-4 is a solution. So we'll have to do that at the end. A student has to buy graph paper and printer paper. The printer paper costs $2 a pack, while the graphing paper costs $3 a pack. She wants to buy at least 6 packs of paper and wants to spend at most 27. So the reason I underlined the 27 in red is because everything else that was underlined in red has to deal with cost again. So we have a cost inequality. $2 for printer paper, $3 for graphing paper, and at most that means less than or equal to 27. I can't spend more than 27, but I can spend up to $27. Then I have to do an inequality based on the number. The number of printer paper and graph paper together is at least 6 packs, so greater than or equal to 6, okay? Means it can't be anything smaller than 6. So those become our inequalities. Now, in doing this, obviously when you want to graph, you want to try to graph, if you want to use the calculator, doing X and Y. So you'd want to identify somewhere on here and say, like, this is my X, that's my Y, so I can refer to it. But in this particular case, I'm just going to do y-intercepts and x-intercepts. So right here, if I put 0 in for P, divide by 3, I get 9. So that means 9 for my graph paper. So on my graphing paper, for my red, it's 9. My x-intercept, what do? I go in and I put 0 in for G. So this is gone. 27 divided by 2 is 13.5. So on printer paper, I go to 13.5, which would be somewhere like right there. Again, this is not going to be exact. This is not a line. It's a line segment because it's only in the first quadrant because we're dealing with positives. Now, before we do the other equation, or inequality, sorry, we have to shade, okay? Now, how do I shade here? Because here's the thing. When it's not in slope-intercept form, it's kind of hard to figure out, do I shade above? Do I shade below? So a good way to do this is let's just pick values. An easy value to pick is the point 0, 0. So if I put 0, 0 in, that's 0 is less than 27. Does that make sense? Sure. So what's that mean? That means I should shade below this one. Don't just look immediately at this symbol in this form and say you shade below. Use a point to determine. Now with the second one, if I put 0 in for P, G is 6. If I put 0 in for G, P is 6. So the intercepts for both of those are at 6 and at 6. Again, this is a line segment. Again, don't just look and say greater than. That means I shade above. Pick a point. So I pick 0. If I put 0, 0 in, that's 0 is greater than or equal to 6. That doesn't make sense. So that means I need to shade above this one. So if I shade above, I get all of this up here. Now, what I'm really looking for is where do they overlap? They overlap in this area right here. So now I can go back to the original question. Is 8, 4 a solution? Well, where's the point 8, 4? We go to 8, and we go up to 4, which is right there. Okay, so this is kind of close because I can't really tell based on my line whether it's in that shaded part or not. So a good way to check is to plug in again. So I put 8 in here, that's 16. 4 in here is 12. 16 plus 12 is 28. 28 is not less than 27. Do the same thing here. I put 8 in here, put 4 in here. That is greater than 6, but not less than 27. So no, this does not work. And if you see, it is just outside that red line right there. So no, that would not be a solution. So here's another example, but hopefully that's enough for you. We're going to go on down to the evaluate, which is on page 562. And on this, you're doing 1 through 23 odd.